Carbon monoxide, or CO poisoning, is the most common form of poisoning worldwide. Just in the US, tens of thousands of people are killed or hospitalised every year by this odourless and colourless gas, which is in boiler, stove and vehicle exhausts, and it's also produced during house fires. At the moment, the only treatment is oxygen, but it isn't very effective and it's often administered too late to make a difference. Now researchers at the University of Pittsburgh have developed an antidote molecule that can circulate in the bloodstream and pull the carbon monoxide from tissues to make it safe. Mark Gladwin told me how it works, beginning with why carbon monoxide is poisonous in the first place.
Carbon monoxide is a molecule that looks a lot like oxygen, and it actually binds to the same binding sites in the body that oxygen binds to. The most classic one is hemoglobin. Now, hemoglobin is the molecule in our red blood cells that makes our blood red, and it transports oxygen from the lungs to the body. Carbon monoxide will occupy those binding sites and prevent hemoglobin from carrying oxygen in the body. It's like drowning, but rather than because water's filled your lungs, carbon monoxide is just occupying those binding sites.
And you can't persuade the carbon monoxide to surrender its hold on our hemoglobin readily. So therefore, it's not just a case of waiting to breathe it out again and oxygen goes back on. It's stuck there for a period of time.
Exactly. So once you breathe carbon monoxide, the half-life, that's the time it takes to clear the carbon monoxide out of the body, is 320 minutes. Now, when you breathe 100% oxygen, which is the therapy that we deliver in the field, that oxygen will compete a little bit with the carbon monoxide, and that half-life will decrease to 74 minutes.
But importantly, that's still far too long for someone whose tissues are now deteriorating because they're not able to get enough oxygen into their tissue.
Exactly. And with carbon monoxide poisoning, the two big organs that seem to be affected are the brain and the heart. And even patients that survive carbon monoxide poisoning, about 25% of them have long-term brain injury.
But you think you can change this?
Yeah, so we've been working for about 3.5 years on a new antidotal therapy for carbon monoxide poisoning. And it's actually based on a small hemoglobin-like molecule that's actually derived from a normally occurring human molecule called neuroglobin, which is a hemoglobin-like molecule that's normally in the brain and the retinal tissues. And we've substituted a few key amino acids in the oxygen binding site, and this molecule binds carbon monoxide 500 times tighter than hemoglobin binds carbon monoxide. So essentially, this molecule becomes like a carbon monoxide trap.
And if you have carbon monoxide bound to your hemoglobin because you've been exposed to the gas, and you put some of this into your body, could it compete with the hemoglobin and pull the carbon monoxide off so that it could start to carry oxygen again?
Yes, that's exactly what happens. And when we mix this neuroglobin, either in a test tube or actually in a living mouse that's poisoned with CO, the CO transfers off of the hemoglobin with a half-life of only 25 seconds.
Where CO is the chemical formula of carbon monoxide, isn't it? So is that what
Yes.
you've actually done? So you give mice some carbon monoxide to mimic someone whose boiler flue is blocked up and their gas stove is poisoning them, and you then can inject this stuff into the blood and it will go around in the blood and pull away the carbon monoxide.
Yeah, so in these studies, we had two models. We had a moderately severe poisoning and we had a lethal poisoning model. In our lethal model, when we infused our neuroglobin antidote, the carbon monoxide levels on hemoglobin dropped 30% and the mice survived. Whereas if we infused a fluid solution of saline, all of the mice died in that model.
Were there any consequences for other tissues in the body of doing this, though? Because we know, for instance, that if you release into the bloodstream a chemical a bit like hemoglobin found in your muscles, that's myoglobin, and marathon runners can get this problem, you can damage your kidneys, can't you? So is there a consequence for injecting this stuff?
That's sort of been our number one safety concern, is could this free hemoglobin-like molecule, could it precipitate in the liver or the kidney and cause damage? And what's interesting is as soon as we infuse it, it binds the carbon monoxide and it actually does filter through the kidney into the urine and it's cleared in the urine. And that half time for clearance, about half of it's cleared within 13 minutes.
Are there any constraints on this sort of therapy, though, in terms of the time you have to intervene? Because people who are subject to carbon monoxide poisoning, often they are discovered too late. They've already succumbed to considerable exposure. They have brain damage, for example. And by then, do you think this will be able to help them?
What we see with this therapy is the promise of delivering it in the field. So if this antidote could be carried on fire rescue trucks, on ambulances, one could make the diagnosis in the field, place an IV, and while they're being transported in, the drug could be infused. So we think that this speed, this point-of-care intervention is what could really change outcomes for patients with severe poisoning.
Mark Gladwin, and that work was published this week in Science Translational Medicine.